to Physical Science 3.2 on work and power. So work is defined differently in different places, but in science, the definition of work is using a force to move an object a distance when the force and the motion of the object are in the same direction. So on your formula sheet, let's add the formula for work. Work is equal to force times distance, or W is equal to F times D. But we don't always have to just find work. Sometimes we'll have to find force. Force is work divided by distance, and distance is work divided by force. Remember that you do want the variable, the word, and the units. Work is measured in joules, force is measured in newtons, and distance is measured in meters. So the unit of work could be a Newton meter. Be sure this gets added to your formula sheet. Here's an example. If a man pushes a concrete block 10 meters with a force of 20 newtons, how much work has he done? Well, work is equal to force times distance. A force of 20 newtons times a distance of 10 meters would be work of 200 joules. How much force is needed to move a box 200 meters if 3,000 joules of work were produced? This is a force question. Force is work divided by distance. 3,000 divided by 200 would be 15 newtons of force. How far can a box be moved with 5,000 joules of work using a force of 160 newtons? This is a distance question. Distance is work divided by force. 5,000 joules divided by 160 newtons is 31.25 meters. Part of 3.2 is also power. Power has many different definitions. But in science, power is the rate at which work is done. So on your formula sheet, let's add a formula for power. P is W divided by T. W is P times T, and T is W divided by P. P stands for power, measured in units called watts. W is work measured in joules, and T is time in seconds. So what is the power rating of a machine that can do 6,000 joules of work in 15 seconds? Power is work divided by time. 6,000 divided by 15 would be 500 watts. How much work can be done with a 350 watt machine produce in 30 seconds? Work is power times time. 350 times 30 would be 10,500 joules of work. And how long would it take a 70,000 watt engine to do 500,000 joules of work? Time is work divided by power. 500,000 divided by 70,000 would be 7.14 seconds. So force is mass times acceleration. Work is force times distance. So work could be written as mass times acceleration times distance. Work makes me mad. Mass, acceleration, and distance. And since power is work divided by time, power could be mass times acceleration times distance divided by time, or power makes me mad over time. So how much work is done in pushing an object 7 meters across the floor with a force of 50 newtons and then pushing it back to its original position? How much power is used if this work is done in 20 seconds? This is a two-tiered problem. First, let's find the amount of work necessary. Work is force times distance. The force was 50 newtons, a distance of 14 meters there and back again, to get a work of 700 joules. If that work was done in 20 seconds, 700 divided by 20 would be 35 watts. Not even enough to power a standard light bulb. Thanks for watching.